All right, there's a lot of examples in this lecture, but there's just two more. Just two more. All right, so you'll be well prepared for the homework, hopefully. So in example 12, it says a sales manager at a local sporting goods store plotted the sales in units of $10,000. That's something to be careful of with the homework. Sometimes they give you units in not just dollars, but tens of thousands of dollars. Okay. So he's plotting 10 units of $10,000 versus time for the last 5 years and found that the points lie approximately along a straight line. Okay. So he's taken the data and plotted the points and drawn a line that fits it fairly close just by eyeballing it looks like. And so by using the points corresponding to the the first and the fifth years, find an equation for the trend line. Okay, so the first and the fifth years, that's these points here. So let me actually mark it in red. So the first year is here, and the fifth year is here. So we've got 2 points, and so we can calculate the slope, right? Because we really need the slope and 1 point to write the equation of a line. And so let's start with these 2 points. We have the point 1 comma 20 looks like, and then the other point looks like it's 5 comma 60, right? So so there's our 2 points, and then we can calculate the slope. So the slope between those 2 points would be 60 minus 20 over 5 minus 1. So we get 40 over 4, which is equal to 10. Okay, so it looks like the sales are increasing by $10,000. So let's be $100,000, I guess. $100,000 a year. All right. So now we have the slope, and so we can use the point slope form of a line. All right, and I just have to pick one of these points. It doesn't really matter which point I pick. They'll both give me valid equations for the line. And if I write it in if I get the equation for the line and then rewrite it in terms of or in point slope form, then slope intercept form, then you'll see that they're the same. But anyway, let's do this. Let's just pick that first point, 1 comma 20. So we're going to use the point slope form of a line. So we get y minus 20 is equal to the slope, which is 10, and then x minus 1. All right. So I'm actually going to rearrange this line. So I get an equation for y, which is the sales, in terms of time, which is x. So, all right. So I'm going to distribute the 10. So I get 10x minus 10, and then I'm going to add 20 to both sides, so that I get an equation for y. So if I rearrange that, then I get y is equal to 10x, negative 20 plus 10 gives me 10, so plus 10. Right, so there's the equation for my line. And then this part B is asking what sales figures can be predicted for the 6th year. So now that we have an equation for the line, we can put in any value of time, which is the x variable, and calculate what the sales are, which is the y variable. So I'm just going to plug in the value x equals 6. And so I get y is equal to 10 times 6 plus 10. So that's telling me that that gives me, looks like 60 plus 10, which gives me 70. Now we have to watch the units here. This is in $10,000. So this is 70 $10,000, right? $10,000, which is a really weird way to say it. But so it's 70 tens, which is 70 tens is 700. So we could actually say this is equal to $700,000. Okay, so so there you go. Weird units. All All right, got one more video and I'll meet you there. All right, so we learned about the point-slope form of a line, and we learned about the slope-intercept form of a line. And the general form of a line is just some constant times x plus some constant times y plus some constant equals 0. If it's in that form, it's in general form, okay? So if you look at example 13, what we have is an equation for the line in general form, okay? So we could rewrite this. We could actually rearrange that equation and put it in probably the nicest form is the slope-intercept form. The nice thing about the slope-intercept form is the fact that you can read the slope and the intercept right off of it, and it's really easy to graph. All right. But sometimes you don't want to have to deal with the algebra. Sometimes you just want to graph the line and not have to do the algebra. So what I'm going to do is show you a little trick for how you can graph a line without having to do the algebra. Okay. So I want to graph this line, and what I'm going to do, I'm going to calculate the x and the y-intercepts. So the y-intercept occurs when x is 0. So if I just take this line and I plug in 0, right? So I get 3 times 0 minus 4y minus 12 equals 0. All right, so this just goes away. I can add 12 to both sides. I get minus 4y is equal to 12. Right? And then, so then y has to be a minus 3. Okay, so I can just, that's my y-intercept. And the x-intercept occurs when y is equal to 0. Okay, so if I take that same equation and I just plug in 0 for y, I end up with 3x minus 4 times 0, so I'm just not even going to write it, minus 12 equals 0. So x has to be equal, well, that's right, 3x is equal to 12, so x has to be equal to 4. Okay. Now you can probably do that in your head, if you just recognize that, okay, when I put in 0, that term goes away, and then I just want to solve the rest of the equation. All right. And then once you have the x and the y-intercepts, you can just graph those and then connect those 2 points, and you have the graph of the line. You can sketch the graph of the line. So if I wanted to sketch this graph, so let me draw some axes here. There's my x-axis, and let's see how straight I can draw my y-axis. All right, that's not too bad. It's pretty good for me today. All right, that's my y-axis. And so if I just plot those points, 0, comma, negative 3, right? Here's negative 1, negative 2, negative 3. So that's down here. All right, I'm going to label that point 0, comma, negative 3. I'm going to plot that point, and then I'm going to also plot the x-intercept, which is 4, comma, 0. So 1, 2, 3, 4. 4, comma, 0 would be here. And it only takes 2 points to form a line, so I'm just going to make it pretty and make it in red, right? So I can just draw a line between those 2 points. Okay, and that's a sketch of the line. All right. So now we might also be asked if a certain point lies on the line, and we can tell if a point is on the line if it satisfies this equation, right? Because essentially this line is a set of all the points that satisfy that equation. All right, so all I need to do is plug in this x and y value and see whether the equation is true, right? I just want to see if it satisfies the equation. So my equation is 3 times x, so I'm going to put 2 in for x. And then minus 4 times the y value, which is a negative 3 halves. And then minus 12. And I want to know, does that equal 0? Well, let's see. I've got basically 6, and then I get negative times negative, so I can just make these positive and cancel a factor of 2, right? So this becomes 2. 2 times 3, so I get 6 plus 6 minus 12 equals 0. And yes, that checks out. So this is a yes. Yes, this point lies on the line because it satisfies this equation. I can plug the number in and the equation is true. Okay. Now let's check this other point. We have this other point, 1 comma negative 2. Does that lie on the line? Well, I can just put the values into the equation and test it to see if this point satisfies the equation. So the x value is 1, and then I have minus 4 times negative 2 minus 12. And does that equal 0? Does that equal 0? Well, let's see. I get 3 minus, so this is a negative 4 times a negative 2, which becomes a positive 8. And then minus 12. And that's 11 minus 12, so that's a negative 1. That is not equal to 0. So this is a no. No, that point does not lie on that line. Okay? So just remember that the line that we're graphing is basically the set of all the points that satisfy the equation, right? We can put any point, if we pick any point along the line, on this line, it should satisfy the equation. And all the points that are not on the line do not satisfy the equation. All right? All right. Well, I think that's it. That takes care of this lecture. This was a lot of lecture here. But anyway, you should be well prepared to work on the discussion questions, and I'll see you in class.